All right, good evening, ladies and gentlemen. It's great to see all of you. Thank you for allowing us to present to you. I know that I'm the last presentation stopping you from rushing out those doors. So I try to be as quick and precise as possible with giving you enough information to where you're still interested throughout this presentation. So, Davis, you with me? Can you hear me? Great. All right, so what I'd like to do for you before I begin exactly explaining to you what VP&S is, I want to bring you through the thought process that our team had when picking this topic for our senior design class. So we sat around a table and we were thinking, what can we do? What can we do that's worthy, that keeps us in between the ditches, as our great professor, Dr. Peoples, told us. So we said, well, let's design a processor. Now, I can't do that. Dr. Hain covered that one in 418. And then we said, well, maybe let's fix the Citadel network, because the internet is just not great. Dr. Skinner taught us that's impossible to do. Okay, so we're back to the drawing board. And this is what we decided. We said, what were the things that truly aggravated us being a student at the Citadel? And without a doubt, it was parking. Now, if anybody of you have experienced parking on the campus, hopefully you've had good experiences. My guess is you have. Okay? So, with that in mind, there was 3 problems that we identified on why we chose this topic. Okay? The first one being, there was this thing happening. We couldn't figure it out, but cars were being towed, ticketed, and booted without anybody knowing. To give you an example, I had a classmate of mine, his car was towed, neither himself nor the people who towed the car knew where it was. That's a problem, right? Second guy we want to talk about. Something that I call selective authorization. If you've ever experienced parking in your life, maybe there's a time where you had a reserved spot and somebody took it. Okay? Whether that was driving into Walmart, okay, or was on the Citadel campus. So what happens when somebody takes your spot? Taking somebody else's, right? Okay, well now they're out without a spot. So what are they going to do? You see the problem? Everybody got it? Davis, you got it? All right, that's the second problem. The third problem that we wanted to deal with was how do we make it cost effective? Anybody know what they pay for parking per semester for cadets? $250. That's $4,000 you're paying for parking over the 4 years. Okay? Now, $41,000 Friday State tuition, that looks like a really small number. Okay? So that I don't like to pay $4,000 to park in a spot that I don't have. See what I'm getting? So these were the 3 things that we really said, how can we solve these problems? And so that's how we present to you VP&S. VP&S stands for Vehicle Personal Notification System. And I'm going to bring you through a little overview on exactly how we went about designing this, okay? So I'm going to give you a brief topology of our project. Then we're going to go into what are some of the devices that we used to collect information. Then once we have that information, how we process it, send it over a communication channel, process it again to put it to your phone and say, hey, your car's about to get towed. We might not know where it's going, but it's getting towed. Okay? Still with me, David? All right, thank you. So here's your overview, right? For some of you, you've seen this over and over again, so I apologize, okay? Here it is again. For those who have not seen it, it may look complicated, but by the end of this, I promise you, you'll totally understand it. The key things that I want you to notice is we're using things called RFID. We've also got a couple of displays that we're putting in parking lots. We're using switches that we can interchange with things that I'll explain later. We've got some type of microcontroller that's processing all this information that's coming to us from the parking lot. Okay? And then we're going to send that over some type of communication. Hopefully we learn something from Dr. Skinner. And then we're going to put that in a computer system, email it to you, so that you have everything you need to know about your car. Dean, you with me? Do I need to slow down?
I got a solution.
What you got?
You just cancel all parking on campus.
That's not how we do it here, sir. So, when we first sat down, we're like, okay, Dr. People said, don't worry about what it looks like first, unless you're the water wizards, okay? It's exactly what he said. But we had to know somewhat of what we were going to be collecting, so we knew what devices we needed. So this was our initial design back in September, and our final design looks something like this. Pretty close, okay? So not much changed, And by the end of this, I promise you, you'll understand what's going on here in this picture. So the next thing that I want to talk to you about was what are those two devices that we're using to collect the information that we want to send to you. Okay? Those two types of devices that we're using, one is an RFID technology, and the second one is a basic switch, an active high and an active low. So let's talk about the RFID. Anybody ever travel the interstate and go through a toll booth where they didn't have to stop? Right? What am I talking about? Active RFIDs, right? So if you've ever done that, what happens is you've got a device in your car. And it's going to look maybe something like this if you're from Florida. Florida's a great state, I promise you. Okay? And what's going to happen is they've got these devices called SunPass lanes where you don't stop. It's because this device has an RFID tag that is uniquely identified. Maybe it's something like 12 bytes of data, okay, which is what we're using in our project. So what happens is you're going to go through this reader at the SunPass, and somehow it's going to charge you. I'm not going to charge you, I promise. Okay? So what happens is we're using this to be able to say, instead of having those nasty orange stickers maybe on the top of your car that you can't get off at the end of the year, I'm just going to give you an RFID tag that costs less than $2.50. And then you're going to turn that back into me at the end of the year. Or you can keep it. It's fine. Okay? Your choice. So what you've got is you've got 12 bytes of data that are uniquely identified for you. And maybe it's something like this. You say, well, hey, that's only 10. That's because there's a start and a stop it to break up the different transmissions of the different RFID tags. Okay? All right. Next thing, how are we reading these things? RFID reader. Okay? Serial communication, so it's reading it serial in 8 bits of chunks, right? So the numbers before that we had were in hex. Okay? They were in hex, converting that from the code into the ASCII characters. And each one of those things is to be written in 8 bits of data. We have some things and why we chose that reader. It's got indicator lights. If it's red, we're reading things. If it's green, it's not. Helped in debugging. Our baud rate's 2400. We've got a 5 volts power in this thing. All right, Dr. Mazzar, are you ready? Am I going too fast for you? All right. Next thing we're talking about is switches. Okay. So the first device that we're using to collect this information was the RFID tag. That's helping us solve which problem? Anybody can guess? There was 3 problems I addressed. Anybody know which one this is solving? The RFIDs? Selective authorization. Okay? This is solving selective authorization, so Dr. Askins is not taking my parking spot. Or probably the other way around, because he's got the good one. He's got the good parking spot. So that's what that's doing. So the second device that we're using to collect information is, let's say you're going into a parking garage. Anybody been in these MARTA garages that you see in the airports that got lights down the row? You know exactly where there's a free spot because of a green light indicator. Right? So that's what's happening with these switches is, if we turn the switch on, which we could replace with a motion sensor, same thing. If there's a car and you sense it, it's a high, it's a 1. Okay, same thing with the switch. When you turn on, it's a higher 1 with some configuration. Because Dr. Haynes' head's spinning right now. I said, they're not the same. So I got you, sir. Okay? So what happens is those switches in that 7-segment display that we've got on our board is going to update how many spots are left in that row. How many spots are left in that row? So that's what those switches are using for. So being senior design, trying to graduate on time, we had to dumb it down a little bit so we can get that through. So this is what we've talked about. What's happening at the gate. We're talking about what's happening here at the switches and how we gathering information. So what's the next step? Processing this information, right? Information is no good to us unless we can do something with it. So to help us understand how we're processing this information, I'd like to bring up Cadet Daniel Hubbs to talk about the programming of the microcontroller.
Thank you, Ryan. Again, my name is Daniel Hubbs. I'm going to briefly go over PIC-18's processing. We chose the PIC-18 as our processor because luckily we have an expert here on campus, Dr. Haynes, who is the PIC-18 has some key features we wanted to utilize, like the LEDs on board, switches on board, and the LCD display. It also has a wide array of pins, pinouts on board that we get to utilize. So the programming is pretty simple. This over here is the main program. So always you have to initialize any ports you're going to use, any outputs, any pins. Then we go into mode. So here on campus we have 2 modes that the parking lots have to operate in. Like an Altman lot, the football games, the cadets have to get out of there so that alumni or any civilians can park in there. Well, you know, if we're actively scanning RFID tags, it doesn't really work for alumni to get in there because they don't have their RFID tag anymore. We have to figure out just a way to open the gate up. So we have a little switch that ideally we put in the lockbox, and our personnel would have to go up there and switch it. But for our purposes, the switch is just going to be one of the onboard switches. doors come open, and it'll be the event, special event, football game status. Otherwise, we're just going to check the RFIDs like regular. So initially, we're going to scan the RFID tag. If the RFID tag is within a select range, then they're going to be authorized. So for the Alton lot, let's just say, you know those little orange stickers that Mr. Fauché talked about earlier? They already have, that's how the parking authority already checks our spots already to see if we're authorized them. Because if not, we'll get a parking ticket. So for Alton lot, let's just say 100 to 300. Well, if the RFID tags are selected for that lot to be within 100 and 300, all we have to do is see if the RFID tag is above 100 or less than 300. If it is authorized to go in there, we're obviously going to open the gate, then we're going to send the RFID tag via XB communication to the host computer, change the display, so change how many cars are in the lot, and then close the gate. This also works as our exit gate, because if a car comes in, for our demo practices, if a car comes up to the gate, scan it, it's going to be sent over RFID, over XB, and then the display is going to get changed again. So if it's exiting, the display will be decremented. If it's incrementing, or if they're entering, the gate will be increased. For simplicity, the gate's going to close after a lot of time, but in the real world it'd be based on a sensor. Then we're going to check the spots, so just to check the switches and the parking spots, and then display it on that data on LEDs. The PIC-18 is powered by a 9-volt DC source, and the PIC-18 on board has a 5-volt access. So it can power the XB antenna, the RFID receiver, and the gate modem. The gateway computer is just a host computer, just a PC, has its own power source, and it powers the XB antenna that receives the data from the PIC-18 via a 5-volt USB cable. And then, obviously, a smartphone has its own battery source. That I conclude.
All right, great. If you learned something, give Danny a round of applause. You did a great job. Huh? You learned something? All right. So we talked about collecting information using devices. We talked about processing this data through some type of microcontroller. It means nothing if we can't get it to you as a user, right? Yes? Yes. Okay. Daniel Harrison is going to talk about how are we sending this information over some type of communication chain. So, Daniel Harrison.
Thank you, Fauché. First things first, our communication channel is wireless. We chose wireless communication because it allows mobility, and you can have your gateway PC and your microcontroller as long as they're in a certain range. And we decided to use the XB, same as 2 other teams have used. And once those serial bits come across from the RFID through the XB, they're going to be inputted into the computing system and then emailed out, which we'll get to later. So the XB Series 1 trace antennas they transmit at 2.4 gigahertz, have a 100-meter range, and that's on a good day. Use the 802.15.4 IEEE protocol, and again, importantly, the serial communication, they have that capability. The 2 programs down here I want to elaborate on. XCTU is a program that Digi actually released that allows you to easily configure these XBs. So you can configure your transmitter, and you can configure your receiver, and set your baud rate, and a lot of other things you can do with them. And HyperTerminal is a Windows program that allows us to see these serial RFID tags come in, and it allows us to upload it into Excel, which then allows us to email it out. So as far as communication goes, it's just pretty simple. We're trying to send serial information from point A to point B using wireless.
Alright, Ian Pardo Thompson here, and I'm going to talk about the most important part of our project, which is getting the actual information about your vehicle, if you have to move out of the parking lot or not, to the actual vehicle owner. And what we used in our project was the collaboration between Microsoft Outlook, Microsoft Excel, and a mail merge program in Microsoft Word, which sends out the actual email to a personal computer or your phone. This is the data that is inserted manually by either public safety or whoever would be in charge of inputting the initial data for the car owner, their name, their email, RFID tag number, their license plate number, the car make, model, and their color of their vehicle. And all this information, I'll show you how this is utilized later on in the presentation. Right here up top is the data that, like I said, is inserted manually by public safety or whoever's going to be in charge of that. And including this information at the bottom, which is the email, and what's actually going to be input, what's really getting gathered by the PIC team is right here in this column, the data column. This is the RFID tags that are being stored into the Excel document, which happens after the RFID tag is scanned at the RFID reader at the gate. The count column counts how many times the RFID tag is scanned. That's going to be an even or an odd number. And the odd column comes into play comparing this data right here. And before I talk about the odd column more, I'm going to tell you what's in these cells right here. In the owner, make, model, car, license plate, RFID tag, and email, there's an if-then function which says that if the odd function cell is true, which means that there's a 1, then all the data will be inputted into this row right here. If the data is false, they'll be given a 0, and then there will be no data inputted into those cells, which is used directly with the Microsoft Word email template. And I apologize for it being a little blurry if you can't read it or whatever, but this is, just like I said, a basic template of what we're going to have sent out to the person. And these are the header fields that I was talking about: the owner's name, their color, make, model, the license plate number, and the RFID tag number will be inputted into this message. And this message will only be sent if the authorization is changed in the PIC-18, just like Daniel Huff said. If we need to get those cadets out of the parking lot with the authorization being between 1 and 300. If we need them out, then the data will be given a 1, which will then send out this email to those people. Right.
Great. Thanks, Ian. Hey, round of applause for you. You did a great job so far. All right, about a minute away from being done. So we have the overview, right? RFIDs, processing information using devices. We're taking that data, and we're processing in the microcontroller. We're sending it. You have an email, right? I solved your problem, somebody taking your spot. And with the email, I've attempted to stop you from getting towed, ticketed, or booted, because you know if you're not supposed to be in a place you're not supposed to be. All right? So how do we make this happen budget-wise? Budget-wise, as a senior design project, we're about $236. Now, how am I saving you costs if this were implemented? To get a good, accurate reader to be implemented in the CITL system, it's going to cost you about $500. So if, let's say, you have 4 parking lots, you can pay that with the amount that it takes one person to park on campus over the 4 years. And then each user will only be responsible for $2.50 for a tag. Okay? So I'm saving you some costs there. So that was number 3 that I solved you. Some of the risk analysis that we had to take into effect. We didn't want to hit anybody with the gate. So like Daniel Hubb said, we put a timer for 30 seconds, and one of the things we do if we implemented this was actually putting sensors, like a weight sensor, to make sure the car was already gone. So some of the things like that, scaling the project course, what happens if you have weather, inclinations, and things like that. I talked fast, I gave you a lot of information. What I hope is that you learned a couple of things. We're trying to improve parking, and hopefully you learned enough to smile at the end of the day. If you enjoyed the presentation, please give a round of applause. If you didn't, clap anyway. Okay? All right, that's all I got. Does anybody have any questions? Any questions for us? Which guy?
you understand me. But, hey, so this could control, making sure we know when cadets left on the program too.
Yes, sir.
But also let us know when a cadet is parking in a faculty spot as well.
Trying to promote it, sir.
Oh,
Yes, sir, you're right.
yeah, I mean, there's a lot of things to go with it.
Absolutely, sir.
Your communication architecture from the RFID to the PIC-18 to the XP to sort of the host computer, you see that host being her parking lot or at the parking lot, or that doesn't matter, or that the host is where you're going on the email. You're going to send an email there.
Yes,
You're not
sir.
going to some other central computer with wireless.
No, sir, the host computer would, I guess on the Citadel campus, be actually in public safety, and for the multiple parking lots, for our project, we use the XP Series 1, but XP Series 2,
That's what I was getting at.
yes, sir, you could actually do multiple parking lots.
You can cover all the parking lots with XP going to a host with longer range XP.
Yes.
And what's this about the pink car?
Had to argue, spice it up a bit, sir.
So I'm hoping the car is the license plate for.
All right, thank you very much for your time. Have a great evening.